Today we're going to solve equations that have multiplication in them, and we're also going to solve equations that have absolute value in them. So let's start by solving the following equations. The directions will say solve. Make sure you show all your steps. Number 1, if you have 2 times parentheses y minus 2 is equal to negative 6. We have an equation, it has parentheses in it, and we're going to have to use the distributive property to get rid of the parentheses. So that'll be the first thing we do because we're trying to get y by itself, and right now it's in the middle of the parentheses. So we're going to multiply by 2, we get 2y. We multiply the second term by 2, and we get negative 4 equals negative 6. So we use distributive property to get rid of our parentheses. Okay, now to solve for y, we're going to add 4 to both sides. And we get 2y is equal to negative 2. One more step, we divide both sides by 2. And we get y equals negative 1. So that really wasn't too bad. All right, the next equation looks like this. Number 2. We have 5x squared plus 43 equals parentheses x minus 1 times 5x plus 6. Now you'll notice in this equation we don't have any parentheses on the left-hand side, but we have 2 sets of parentheses on the right. We have a binomial times a binomial, which means we're going to have to use distributive property twice. So we don't have to do anything over here, so we'll just recopy our 5x squared plus 43, and we're going to distribute. We have x times 5x, that would give us 5x squared. And x times a positive 6 would be plus 6x. Then we're going to take our second term, including the negative sign, and we're going to distribute it to everything in the second set of parentheses. So you can see we're just reviewing our distributive property problems that we did earlier. Negative 1 times 5x would be negative 5x, and negative 1 times positive 6 would be negative 6. All right, now, can you see something on both sides of the equation that are the same that we can cancel? Let's get rid of the 5x squareds. All right, so we have 43 is equal to 6x minus 5x simplifies to just plain old x minus 6. We're actually almost done. We have one more step. To get x by itself now, all I have to do is add 6 to both sides. And I have x equals 49. All right, we have one more problem that I'd like to do, and it's the most complicated one you'll see. Let me turn the page. We're still solving. We're going to solve number 3. If you have x plus 3 times x plus 4 is equal to x plus 1 times x plus 2. Now, if you would like to try this yourself first, you can pause the video and give it a shot, and then you can start it up again when you're ready. So go ahead and pause the video. Okay, now I will go ahead and work it. All right, so we're going to distribute. X times x is x squared. X times a positive 4 is a positive 4x. Start all over again with this positive 3. Distribute the positive 3. I get positive 3x. Positive 3 times positive 4 is positive 12. I'm done with that side, getting rid of the parentheses using distributive property, and I'm going to do the same thing to the other side. So on this side, I have x times x, which is x squared, x times positive 2, which is positive 2x. Positive 1 I'm going to take and I'm going to distribute that. I get a positive 1x. And positive 1 times positive 2 is positive 2. Again, we look on both sides and we see that we have an x squared on each side, so we're going to just cancel those out. Collect like terms, I have 7x plus 12 is equal to 3x plus 2. All right, now I need to get my x's on the same side. So I'm going to move my 3x to the other side by subtracting it from both sides. And I get 4x plus 12 is equal to 2. Subtract 12 from both sides. I get 4x is equal to negative 10. Now, in the next step, when I divide by 4, it's not going to divide it evenly, but that's okay. I'm just going to get a fraction answer. Divide both sides by 4. I'm going to get x equals negative, and I can divide the top and the bottom by 2, and I get negative 5 over 2. So you can see how to solve equations that have parentheses in them. You use your distributive property to get rid of the parentheses, then you collect like terms, and then you move all your x's to one side, all your numbers to the other side, and you'll have your answer. All right, the second part of this lesson is solving equations that include absolute value in them. So equations with absolute value. The directions will say, well, in this first part, it's going to say to find all the solutions. Well, that seems to imply that there's going to be more than one. Let's look. We'll call this number 4. If you have the absolute value of x and it's equal to 5. Well, let's review. What is the absolute value? If you take the absolute value of a number, that means how far is that number from 0 on the number line? Well, 7 is 7 away from 0. If you take the absolute value of a negative 7, how far is negative 7 from 0 on the number line? That is also a positive 7. So when you take the absolute value of any number, you're going to get a positive answer. So I want to know what could x be that if we took the absolute value of it, we would get a positive 5. Well, you can see over here when I did this problem, I got a positive 7 two different ways. I put in a plus 7 and I put in a negative 7. So what would happen if x was negative 5? If I plugged in negative 5 to this x and I take the absolute value of it, I would get positive 5. Or what happens if I put in positive 5 for x? If I put in a positive 5 right here and I take the absolute value of it, I also get a positive 5. So I actually got 2 answers, and you will get 2 answers most of the time when you take the absolute value of a variable in an equation. Well, let's try another one. Number 5. What if you have the absolute value of x is equal to 124? What can I take the absolute value of and get 124? Well, I would say x equals negative 124 or x equals a positive 124. Okay, number 6. What if I had the absolute value of x is equal to a negative 6? What could you take the absolute value of and get a negative 6? Well, remember, when you take the absolute value of any number, you get a positive answer. So how are we going to take the absolute value of something and get a negative 6? What could we put in for x? Well, there's nothing we could put in for x and get a negative answer for an absolute value. So what would we say the answer is? We would say no solution. There is no number that I could put in for x and get a negative 6. So let me show you this next problem here. Number 7. If I have the problem, the absolute value of x minus 5 is equal to positive 10. I want to know what x could be to make this true. Well, this one, you could probably think about it and come up with some numbers that if you put in for x and subtract 5 and take the absolute value of it, you would get 10. But we don't want to have to think that hard. So we are going to use the rule that we actually used in number 4 and 5. You don't realize it, but we learned the rule of how to get rid of the absolute value signs when it's in an equation. What did I do? Well, you notice that this absolute value right here is by itself. There's not a number on the outside of it that's multiplied or added or subtracted on the other side. So, if absolute value is by itself and is equal to a positive number, we can take the absolute value signs off of the x, but we have to write the problem 2 times. To take the absolute value sign off of this x, we just pulled the x out and we made this number negative. Or we pulled the x out here and we wrote the same number there, we left it positive. The same thing happened in this problem. To get rid of the absolute value, I rewrote the x and I made this number negative. And then I rewrote the x again and I made it positive. So in this problem, we're going to do the same thing. We have absolute value by itself equal to a positive number. We can take whatever's inside the absolute value out, as long as we set it equal to the other number that's negative, or we take the absolute value out, and I meant to take the absolute value out, try that again, equal to exactly how it looks without the absolute value. So to get 2 answers, I have to take my absolute value problem and I have to write it 2 times. The first time I write it, I make this number negative. The second time I write it, I make this number positive. And now I have 2 equations to solve and I can find 2 answers. So right here, if I add 5 to both sides, I get x equals negative 5. Or here, if I add 5 to both sides, I get x equals 15. And we can actually check our answers and make sure they're right. If you plug in negative 5 right here, you have negative 5 minus 5. That is the absolute value of 10. And the absolute value of 10 is 10. So that checks. If you plug in 15 to the same equation, you have 15 minus 5. That's the absolute value of 10. Does that equal 10? Yes, because the absolute value of 10 equals 10 and they're equal to each other. So on the next page, I'm going to go ahead and write down the rule that we just used in generic form. Okay, if absolute value is by itself and equal to a positive number, then you will use this rule to get rid of the absolute value, or we'll say to remove the absolute value. The absolute value has to be by itself, and it has to be equal to a positive in order to use this rule. You have the absolute value of something, x, is equal to a positive number. To get rid of the absolute value, you take it out of the absolute value and you set it equal to that same number, but you make it negative. Or you write it exactly how it looks without the absolute value. So let's solve a couple more problems that have absolute value in them. I believe we're on number 8. If you have the absolute value of 3x minus 5 is equal to 16, we want to find what are the possible solutions for x. And we know when we're solving an equation with absolute value, we should get 2 answers. Absolute value is by itself, it's equal to a positive 16. So I'm going to rewrite it. 3x minus 5 is equal to, and I'm going to take this 16 and I'm going to make it negative. Or I'm going to write it again without the absolute value and write it exactly how it looks up here without the absolute value signs. And now I have 2 equations to solve to find my 2 answers. I'm going to add 5 to both sides. And I get 3x is equal to negative 11. Divide both sides by 3. And I get x equals negative 11 over 3. Or I'm going to add 5 to both sides here. I get 3x is equal to 21. Divide by 3 on both sides, and I get x equals 7. And I found 2 answers for x. Why don't we try one more? In fact, why don't you guys try this next one and pause the video and try it yourself first, and then you can play the video again. Number 9. If you have the absolute value of 7 minus 8x and it's equal to 1. Well, we have absolute value by itself. There's nothing on the outside of the absolute value, and it's equal to a positive 1. So we are ready to use our rule. So pause the video and try it yourself. See if you can find the 2 answers. Okay, hopefully you got 2 answers, so let's see if you're right. All right, we're going to take off the absolute value, so we're going to say 7, hold on just a second, 7 minus 8x is equal to negative 1, or 7 minus 8x is equal to positive 1. You solve both of those equations. You subtract 7 from both sides. You have negative 8x is equal to negative 8. Divide both sides by negative 8. And you get x equals 1. Or you subtract 7 from both sides again. You get negative 8x is equal to negative 6. And when you divide by negative 8 on both sides, you're going to get a fraction. Now your negatives cancel, and then you can divide the top and the bottom by 2. So you end up getting 3 over 4. So there are your 2 answers. Hopefully you guys got those answers. Okay, let's just do a couple more examples that you might see in your homework. Let's try number 10. Suppose you have this problem. 4 times the absolute value of x is equal to 80. Now you notice something a little bit different about this problem. The absolute value is not by itself. You have a 4 on the outside. So You cannot use your rule until you get rid of that 4. So how would we get the absolute value by itself? What's the opposite of multiplying by 4? Well, you would divide by 4 on both sides. So if I divide both sides by 4, I'm going to get the absolute value of x is equal to 20. Now, I have absolute value by itself and it's equal to a positive number, so I'm ready to use my rule. I take my x out of the absolute value and I set it equal to this number, but I make it negative. Or I take that x out of the absolute value and I set it equal to exactly what I see, just without the absolute value. Notice that my x's are now by themselves. I'm actually done. My two answers are negative 20 and positive 20. So, what about this next problem? Suppose you have, on number 11, suppose you have the absolute value of 2x is equal to negative 8. I am ready to solve this equation. My absolute value is by itself. However, what's on this side? And most of the time, people won't pay attention to that until they start to use their rule. And they'll start to use their rule and they'll say, okay, I take the 2x out and I make this number negative. And then they're like, oh wait, that number's already negative. So that's a warning sign. That means this absolute value, if you take the absolute value, no matter what's inside here, if you take the absolute value, will you ever get a negative answer? And the answer is no. And so that's why this is no solution. You cannot take the absolute value of anything and get a negative answer. Now, that leads us to this last example. Number 12. Number 12, it says if you have negative 5 times the absolute value of x plus 2 is equal to negative 10. Okay, now a lot of times when people see this problem, they see the negative 10 over here and they say, oh, this is no solution because I have a negative on the outside. But you don't ask yourself that question about this number until the absolute value is by itself. Is the absolute value by itself? We have this 5 on the outside. So we need to get rid of that, okay? And so what's the opposite of, if we're trying to get this absolute value by itself, what's the opposite of multiplying by negative 5? We're going to divide both sides of my equation by negative 5. Why? That gets rid of those right there. And what's left over? I have the absolute value of x plus 2 equals, what happens over here? I had a negative 10, but if I divide by negative 5, my negatives cancel out. And I have 10 divided by 5, which is 2. And you can see that I now can use my rule. I have absolute value by itself, and it's equal to a positive number. So I'm going to take out whatever's in the absolute value, and I'm going to set it equal to a negative 2. Or I'm going to take out my absolute value and I'm going to set it equal to a positive 2. I'm going to solve these equations. I subtract 2 from both sides and I get x equals negative 4. Or I'm going to subtract 2 from both sides and I get x equals 0. And so I have two answers to a problem that some people would have said there's no solution because they saw that negative on the outside. If you can get rid of that negative, then you can use your rule and you'll find answers. So you don't worry about this negative sign right here until you get the absolute value by itself. We had to get rid of this negative 5 right here. Okay, you'll get to practice these types of problems in your homework today. That is all for today.